Hi everyone, this is the section 4.5 video called Completing the Square, and this is going to be the third approach that we're going to take to solving quadratics. We've already looked at how to solve them through graphing, either longhand or on our calculator, and then we've also looked at solving them through a factoring approach. Both of those are very valid methods. Factoring can only be done if the function is factorable, and graphing is I guess most useful if we can use our technology in case we end up with roots that are decimals. This third approach is going to involve perfect square trinomials, and the first thing that we have to look at is this square root property, because that's going to be part of the whole process. Now, this square root property can be used to solve quadratic equations if we have a certain situation. If the left side of the equation that we're trying to solve is considered to be a perfect square trinomial, we're going to apply this idea of the square root property. And I'll review again what makes up a perfect square trinomial with the two examples that we have below. So in these two examples, I'm going to ask you to use the idea of this square root property, which I'll illustrate by doing, to find out what our solutions are here. So the first thing we have to assess is whether the left-hand side of our equation is considered to be a perfect square trinomial. We do not, in these situations, have to have our equations set equal to 0 like we've had to do with graphing and factoring. In this situation, we look at the left-hand side over here, and we assess whether the first term is a perfect square and the last term is a perfect square. If those are the situations, like this is x being squared and this is 3 being squared, if we multiply those values that are being squared together and we double them, so 3 times x, and then we double it, and we get the middle term, that's considered to be a perfect square trinomial. So if we have a perfect square trinomial, what we can do is we can factor this into the quantity of x plus 3 squared. The x and the 3 are the two values that were being squared for the first and the last terms. We use a plus sign because there's a plus sign in the original example. And then we can say that this equals 36. Now, the variable that we want to solve for is inside a quantity symbol. So to undo that quantity symbol and get the variable out of it, we're going to square root both sides. So when I square root both sides, I get x plus 3 equals the positive and negative root of 36, square root of 36, which is 6. To solve for x, I'm going to isolate the x and say x will equal negative 3 plus or minus radical 6, which turns out to be negative 3 plus 6 is 3, and negative 3 minus 6 is negative 9. So through the square root property, because I had a perfect square trinomial on the left-hand side, I find out that the solutions to this quadratic are x equals 3 and x equals negative 9. Those, again, are the two places where graphically the graph, if we set it equal to 0, would cross the x-axis. Now, the second one here, x squared minus 10x plus 25 equals 27. Again, we're going to assess whether we have a perfect square trinomial here by looking at the first and the last terms. This is x being squared. This is 5 being squared. So that criteria is met. If we multiply the x times the 5, we get 5x and double it. That gives us 10x. I'm not concerned about the sign. I'm only concerned about the product there. So this will factor into the quantity of x minus 5 now, squared equals 27. Square root both sides, and we get x minus 5 equals positive and negative. Let me write that again. The quantity of x minus 5 squared equals 27. We square root it, and we get x minus 5 equals the positive and negative square root of 27. Which in turn gives us x minus 5 equals positive and negative 3 radical 3, because that's the square root of 27. And in turn, we end up with x equals 5 plus or minus 3 radical 3. These are our two roots, 5 plus 3 radical 3 and 5 minus 3 radical 3. Now, we're going to leave our answers exact, so I'm going to ask you to leave them with radicals in them. It doesn't help us really understanding what the actual solutions are numerically, because we'd have to kind of guesstimate what 3 radical 3 is and add and subtract that onto the value of 5. But exact answers would be left in radical form. So this would be considered to be answers that are irrational numbers. That radical 3 is an irrational number, which would make this entire thing irrational. So we can talk a little bit further about that if you have questions in class about what I did here on the screen. But this idea of the square root property is going to be used as we go through this process of completing the square. So if I move on to the next screen, if a quadratic equation does not involve a perfect square trinomial, we can use the idea of completing the square approach to manipulate it into that form. So not every problem is going to be set up like the two that we just did, where you automatically have a perfect square trinomial on the left-hand side, but there is a way that we can turn every single situation into a perfect square trinomial that will help us then use the square root method in order to solve the quadratic. So we're going to focus on this right here, x squared plus 16x plus c. And this is a trinomial. What I want to do right now, this is not part of the solving the quadratics, it's just an exercise in working with the skill. I want to find a value of c that will turn this into a perfect square trinomial. Now the way that we go about doing this is that we take the value of b, so in this case b is 16, we take half of it, which is 8, and then we square that value. So we get 64. When we go through that process and turn our trinomial into x squared plus 16x plus 64, that's now a perfect square trinomial. We're going to need to go through this routine when we use this whole process of completing the square. Identify b, take half of it, and then square it to find out what this value will become. This then would factor into the quantity of x plus 8 squared. So this is just a little practice for what we're going to see. You may be asked to do a couple rote problems from a problem set that will just ask you to find that value of c to turn this into a perfect square trinomial. So we'll again review in class when I see you and write down any questions that you might have when it comes to a problem like that. Now this next slide is going to be a list of steps. It's important that you get these steps into your notebook. Because it's going to be the step-by-step process for what you need to follow when you solve these quadratics by completing the square. The first thing that you need to do is assess whether your a value, that leading coefficient of 1, that a value is equal to 1. So if a is not equal to 1, we need to divide the entire equation by that value of a to get it equal to 1. So a has to be 1 in your quadratic equation in order to go through this process. If it's not, you divide everything out by 1, or by that value of a, and I'll show you that in an example that we do in a little bit. We're going to move the c term to the right-hand side of the equation, and we're going to leave a blank where that c term originally was. We're always going to have a plus in front of the blank. This blank is also going to be added to the right-hand side of that equation so that we keep it balanced. So we're going to move the c term to the right-hand side of the equation and leave a blank where it was. Always have a plus sign in front of the blank, and then also add that blank to the other side of the equation in order to keep it balanced. Next, we're going to do what we just did in the previous problem. We're going to take half of b and square that value. That number is going to go in both of the blanks that are now in your problem. And by doing that, what you did is you just created a perfect square trinomial on the left-hand side. So that left-hand side will now be a perfect square trinomial, and you can factor it into that form, x plus or minus b over 2 squared. So it's going to get it in that factored form that we had in the first two problems when we just used the square root property. We also want to simplify anything that we can simplify on the right-hand side. In the end, once that's done, we're going to solve the remaining equation by going through and using the square root property like we did in the first two problems. You may need to rewind this so that you can get all the steps written down in your notebook. and you may want to keep it somewhere where you're going to have it near you as you go through the next few problems and we work through them. So if some of the language isn't clear, make sure you make a note of that so that you can ask me what I mean by it when you come into class the next time. But as I run through the next couple of problems, it may become a little bit clearer. I'm going to do 3 problems that are going to illustrate the completing the square method. Each is going to be kind of unique in their own way. So the first one, I abbreviated completing the square by CTS so we don't have to write it out every single time. The first one I'm going to look at is x squared minus 10x plus 24 equals 0. Now this one happens to be set equal to 0. They may not always be set equal to 0. They do not have to be set equal to 0. So I don't want you to assume that they have to. I'm going to always check to make sure what I have isn't a perfect square trinomial to begin with. And I notice that x being squared is a perfect square right here. But 24 is not a perfect square, so I know I can't just simply use the square root property in order to solve this. So what I'm going to do is the following. I'm going to take and assess whether my leading coefficient is 1, and it is in this case. I'm going to move the 24 to the other side, and I'm going to leave a blank on the left-hand side where I do that, and then I'm going to add that blank to the right-hand side. So simply move the constant over to the right-hand side, but left blanks where it was, and then on the right-hand side to balance it. To figure out what I'm going to put in that blank, I'm going to take the middle term, the coefficient of the b, which in this case is negative 10. I'm going to divide it by 2 and square it. So that gives me 25. That number goes into both of these blanks. I've got to put it on both sides in order to balance the equation. What I did by doing that process is create a perfect square trinomial on the left-hand side. We're going to factor the perfect square trinomial into x minus 5, that quantity squared, equals the simplified right-hand side 1. And now this looks an awful lot like what we did in the first 2 problems. In order to solve this, we'll square root both sides. X minus 5 equals positive and negative 1. And then x will equal 5 plus or minus 1. And simplifying that, we'll get x equals 5 plus 1 is 6, and 5 minus 1 is 4. So these are the 2 solutions for that quadratic through the approach of completing the square. We would have found the same answers if we went through and factored it, or if we went through and did this approach by graphing. In the second problem, 2x squared minus 7x plus 5, the first issue that we run into is that we have a leading coefficient other than 1. So I need to get this into the situation where the leading coefficient is 1. I'll divide everything through by 2. So this is x squared minus 7 halves x plus 5 halves equals 0. Now, you non-lovers of fractions, or yeah, I guess non-lovers of fractions are going to maybe dislike these types of problems because you are going to see fractions from time to time. I need to move the constant to the right-hand side, x squared minus 7 halves x, leave my blank, and add my blank on the right side. Now to figure out what I put in those blanks, I take the negative 7 halves and divide it by 2 and square it. So negative 7 halves divided by 2 is the same as negative 7 halves. Dividing by 2 is the same as multiplying by 1/2. So I'm going to square that. So that gives me negative 7/4 squared, which is 49/16. 49/16 is going to be the number that gets added, whoops, into both of those blanks. Now to factor, the number that I got right here, or the square root of this value, it's either the 7/4 or the square root of that value, which is the same, is going to become what goes in to the factored form. So we have the quantity of x minus 7/4 squared equals, when I simplify this, negative 5 halves is the same as negative 40/16, and I'm adding 49/16 onto it, which will leave us with 9/16. So using the square root property, now you guys can do that on your calculator if you don't want to do it longhand, but make sure you put it in fraction form, please. If we use the square root property, we get x minus 7/4 if we square root the left-hand side. And if we square root the right-hand side, we get plus or minus 3/4. When you square root a fraction, you square root the numerator and square root the denominator. I'm going to solve this by saying x equals 7/4 plus or minus 3/4, which in turn will be 7/4 plus 3/4, which is 10/4 or 5/2, and x equals 7/4 minus 3/4, which is 4/4 or 1. So the two solutions are x equals 5/2 and x equals 1. Again, we would get these answers if we factored or graphed this equation as well. And both of those methods would work for these, and we can talk about that in class, how both of them work as well. So I kind of anticipate there to be questions on the approaches taken here and the methods that I used, because it does get a little confusing from time to time, especially when you hear it for the first time. The last problem that I'm going to do for you is going to be another completing the square problem, but it's going to bring us into a little bit different of an answer. So when I look at this one, solve x squared plus 8x plus 22 equals 0, I'm going to go through that same process. Leading coefficient is 1, so I'm good there. I'm going to move the 22 to the right-hand side. X squared plus 8x plus that blank that where the 22 was equals negative 22 plus the blank to balance it. To figure out what to add in that blank, I'm going to take the 8 for the b value, divide it in half, and square it. So that leaves me with 16. The left-hand side is a perfect square trinomial that factors into the quantity of x plus 4 squared. That's the value I got when I divided b in half, equals negative 6. So we've got to square root both sides now. The square root of x plus 4 squared is x plus 4, and that's going to equal the positive and negative square root of negative 6. Now, this is where what we just did in the previous section is going to tie into these ideas here. The positive and negative square root of 6, or square root of negative 6, is going to bring us into the complex number system when we simplify it entirely. So that gives us x plus 4 equals positive or negative I radical 6. Remember, we can't leave it as the square root of a negative number. We've got to pull the I out. When we go to simplify this, we say x will equal negative 4 plus or minus I radical 6. Now, I can't combine a real number with an imaginary number. Remember, that leads us to a complex number. So my two answers are right here on the board. X equals negative 4 plus I radical 6, and x equals negative 4 minus I radical 6. The plus and minus indicates the two in existence right there. So what that means is this problem would not be factorable, so we couldn't do it by factoring. It also means that when we graph it, this graph would be floating somewhere above the x-axis. We know it's a smiley face parabola because of that positive leading coefficient, and it's got a y-intercept of 22. So whatever side it falls on, we know that it turns before it ever reaches the x-axis. And in that situation before, we would have said that there was no solution. But because we now know something about the complex number system, we can identify two solutions to it that happen to be complex numbers. So this is a new piece. Besides the process of completing the square, you're also going to start to see solutions to quadratics which involve the complex number system. We will again do a couple practice problems in class, and then we'll be able to do a problem set on your own. So come in again with any questions that you might have. That's the last problem I have for you to do on here. So, you know, review, rewind if you have to digest a little bit more. And then I will see you in class next time. Thanks for listening.